Good day everyone, my name is Akaru Menzwabe from Nigeria. In this video, we shall be talking about the design steps for simply supported one-way solid slab, which is part 1 under one-way solid slab. In subsequent videos, we shall be taking some design examples. Kindly subscribe to our channel and stay tuned for more videos on reinforced concrete design. Now we shall be talking about the design steps in designing a one-way solid slab. First, you have to design the slab as a rectangular beam. If this is your LS, LY, which is the longer span, and LS, the first thing you need to know to check the ratio between LY and LS. If it is greater than or equals to 2, you design as one way. Then you consider 1 meter by 1 meter. 1 meter by 1 meter to take your breadth as 1 meter when designing a slab. When designing a solid slab, your breadth should be 1 meter. Initial proportioning. We have to get the initial sizes before we design. First of all, we have to get the minimum effective depth, and we get this from the span versus effective depth ratio, which is table 3.9 of BS 8110. BS 8110. Then we now multiply it by the modification factor. Take your modification factor as 1.3. This is the first step you take to get your D, initial depth, your span, which is your LS, over the basis ratio from your span over effective depth ratio times your modification factor. There you will get your D. This is your D from the middle of reinforcement to the end, and the total height is your H. Your H is D plus reinforcement diameter over 2 plus cover of reinforcement. Assume T is equals to 12. Diameter of reinforcement as 12. Then next, your cover. To get your nominal cover, you get it from table 3.4. So from table 3.3 and table 3.4, you check for fire resistance and durability of concrete. So you pick the lesser of both to get your nominal cover of concrete. If you want to pick your nominal cover from table 3.3 and 3.4 BS 8110, you consider two things: your durability of concrete and your fire resistance. So for your durability, you consider the condition of exposure. If your condition of exposure is mid, we have different conditions of exposure: the mid, moderate, severe, very severe, most severe, and abrasive. So if your condition of exposure is mid and your characteristic strength of concrete, you are taking like grade 30, that's C30, and mid condition, your nominal cover will be 25 mm. Then if you have to consider your fire resistance, assuming you are considering fire resistance of 1 hour, which is this. Other things you need to check out for, if you are designing for beam, simply supported, you take your nominal cover from here. Depends on the fire resistance. Then if you are designing for continuous beam, you pick from here. And in this we are designing for floor, which is solid slab, simply supported. So we are considering fire resistance of 1 hour, assuming then our nominal cover will be 20 mm. So now if we have a question of durability and fire resistance, we pick the lesser of these two, and the lesser of this, and this one is 20 mm, this is 25 mm. So we go with this one, which is 20 mm. Then from there, you can get your total depth H, which is H depth plus diameter over 2 plus cover. Step 3 is your final proportioning. You have to determine your ultimate load. To determine your ultimate load, UDL is 1.4 GK plus 1.6 UK.
Good news, good news, good news. For those who have interest in practicing software on reinforced concrete design, and those who want to further improve their software skill on reinforced concrete design, Grand Maya Nigeria Limited now offer an intensive visual and physical software training on reinforced concrete design. The good thing is that we can now go visual and physical. That means we can reach out to you worldwide. Also, Grand Maya Nigeria Limited do steel and reinforced concrete design and detailing. We deliver worldwide. For more information, kindly reach out to us via call on WhatsApp on +234 81 35 65 3805 or email us at admin@grandmaya.com. Thank you.
To determine your ultimate load, UDL, is 1.4. This is the dead load, and this is the life load. This is the factor of safety for dead load, which is 1.4, plus the factor of safety for life load, which is 1.6. This life load is a factor of the function of the building. So to get your dead load is 1. So to get your dead load, GK, first of all, you consider the self-weight of concrete. To get your self-weight is volume of concrete times density. Then you add finishes, ceiling load, if there is ceiling, partition allowance. So other load, permanent load, all permanent load are dead load. Then QK, which is your life load. Like I said, this life load depends on the function of the building. The next step is the structural analysis. Your bending moment. For a simple supported beam, your maximum bending moment, M, is load L over 8. L square over 8. This is how to get your maximum bending moment for a simple supported beam. From the free body diagram, this is where your maximum bending moment will occur for a simple supported beam. This is your free body diagram, and your maximum bending moment is W square over 8. This S square is LS. That's the shorter span. Step 4. Get your K. Your K is moment over characteristic strength of concrete multiplied by the breadth. B should always be 1 meter times effective depth, the square root of effective depth, which is D. Note, if your K is lesser than or equal to 0.156, you design for only tension reinforcement. You design for only tension reinforcement, which is to get the area of tension reinforcement. Your area will be M over 0.95 FYZ. Note, first of all, if K is lesser than or equal to 0.156, you design for only tension reinforcement. It simply means compression reinforcement is not needed. This is your compression zone. You design for only tension reinforcement. For a simple supported beam, your compression reinforcement is at the top. It is not needed. And this M is the maximum bending moment. 0.1595 multiplied by characteristic strength of steel. You can take Fy as 460. Then to get your Z, lever arm times depth. Your Z is LA times D. This is the effective depth. And this is the lever arm. And this lever arm is 0.5 plus square root of 0.25 minus K all over 0.9. That's how to get your lever arm. Multiply by the effective depth to get your Z. Then area of steel. This is condition number 1. Then condition number 2. If K is greater than 0.156, you design for compression reinforcement and tension reinforcement. In this case, compression reinforcement is needed. If this is your tension reinforcement, compression reinforcement is needed as well. It simply means this tension reinforcement will not be sufficient to carry the slab. So compression reinforcement is needed as well. And to get your area of compression reinforcement, this is the formula to get your area of compression reinforcement. This M is the maximum bending moment from W L square over 8. Why this MU? MU is 0.156. Characteristic strength of concrete. The breadth, which is 1 meter, and the effective depth, square. You already know this, where this D is. Then this D1, this is your D1. Or rather, D1 is equals to H minus B. So this how to get the area of your compression reinforcement. Maximum bending moment minus M U, which is 0.156 FCU square over 0.95 characteristic strength of concrete D minus D1. In this case, where your K is greater than 0.156, you get your compression reinforcement. Then your tension reinforcement will now be your compression reinforcement plus 0.156 FCU BD square over 0.59 FY multiplied by 0.775 D, effective depth. So this is how to get your area of tension reinforcement and compression reinforcement. Step 4. Step 5. Then you can check your reinforcement table to get your area of bar spacing. To get reinforcement spacing from areas of bar spacing table, be it may reinforcement for shorter span or distribution bars for longer span, there are two things you consider: the bar size which you are using and the area we got from our design. That's the area required. So if we are using 12 mm reinforcement for main reinforcement, assuming from this table you provide your area, and if you are to provide area, your area to be provided should be higher than the area gotten from design. If assuming we got 490 mm square, the area should be provided should be higher than this, but the difference should not be too much. Like 502 is higher than 490, 566. These two, they should be okay. So the higher the area, the lesser the spacing. If you can check. So if we are using 502, then you trace to the top to get your spacing. Then your spacing will be 225 mm. So if you are choosing 502 mm square as your area to be provided, then 225 becomes your spacing, center to center of reinforcement. So this can also apply to the distribution bars. Step 6. Your distribution bars. For a one-way slab, you design on one way, while the longer span, note, you only design for one way, which is the shorter span. Then this your LY will now be your distribution bar. To get your distribution bar is the minimum reinforcement of slab. The minimum reinforcement, to get the minimum area, A minimum 0.13% of BH. Your minimum area for your distribution bars is 0.13% of BH. Your B is the breadth B, 1 meter, H total height of concrete. So your B is 1 meter multiplied by the total height of concrete. That is 0.13% of this. Check table 3.25. From table 3.25, on B810, you see your minimum reinforcement for slab. So you take this as your distribution bar area. From there you can go to a table to get your spacing. To know your minimum percentage of reinforcement, you have to check from BS 8110 table 3.25, your minimum percentage of reinforcement. So by looking at this table, like I said earlier, slab is being designed as rectangular beam. So the situation, from situation here, you check your rectangular section in solid slab and the minimum for solid slab. If your characteristic strength of steel is 460 Newton per mm square and you are designing for rectangular beam, which is the same thing as your slab, your minimum steel should be 0.13%. So this is your steel as your minimum reinforcement.
The next step is deflection check. Deflection check, your actual span over effective depth ratio should be lesser than your allowable span, which is your limited span over effective depth ratio. Else,